Math lesson number 41, linear function. So let's have a review on function. Function is a relation such that for every value of x, there corresponds one value of y. So let's have this example, set A. So A here is a function. As you can see, if the value of x is 1, there's only one value of y, which is 2. If the value of x is 5, there's only one value of y, which is 3. If x is 3, then there's only one value of y, which is 2. If x is 7, y is 1, which is there's only one value of y, which is 1. Now let's have an example of not function. So b is not a function because, as you can see, if the value of x is 1, there are two values of y. So we have 2 and 3. Again, if the value of x is 1, there are two values of y, which are 2 and 3. In that case, this is not a function. Okay? Now let's talk about a linear function. A linear function is a function of degree 1. So one variable y is dependent on the other variable x. So meaning to say, y here is a dependent variable, x is an independent variable. So meaning y is a function of x. So in symbol, y is a function of x. So whatever you input to x, that will result to y, or y depends on the value of x. So let's have this one. Y is equal to 3x plus 5 is an example of a linear equation. Now turning this into a function, so since y is equal to function of x, we substitute function of x to y. So as a result, we have function of x is equal to 3x plus 5. This is an example of a linear function. Take note, a linear function. Function of x is equal to 3x plus 5. Now let's talk about this one. This one is not a linear function. So function of x is equal to x squared minus 3x plus 5 is not a linear function, but a quadratic function. So this is a function of degree 2. Linear function is a function of degree 1. Now let's have a function of degree 3. Function of x is equal to x cubed minus 5x squared plus 3x plus 5. So this is a cubic function, a function of degree 3. Now our lesson is about a linear function. This is a function of degree 1. And an example of that is this function of x is equal to 3x plus 5. Okay, so a linear function can be graphed. The graph of a linear function is a line. The domain and range of a linear function is the set of all real numbers, meaning to say the domain, the x-coordinates of a linear function are real numbers. So meaning to say the numbers on the Cartesian plane. Now the range of a linear function is the set of all real numbers, meaning to say the y-coordinates of a linear function are real numbers also, meaning the numbers on the Cartesian plane also. So let's have this example. Function of x, so graph function of x is equal to 3x plus 1. And we set x as negative 2, 0, and 2 for easy graphing. Now as you can see, negative 2, 0, and 2 are all real numbers. Now let's substitute these x coordinates to the function. So we have 3 times negative 2 plus 1 is negative 5. So we have function of x is equal to negative 5. 3 times 0 plus 1 is equal to 1. So function of x is equal to 1. 3 times 2 3 times 2 plus 1 is equal to 7. So function of 2 is equal to 7. So let's have the summary of that. Function of negative 2 is equal to negative 5. Function of 0 is equal to 1. Function of 2 is equal to 7. Now, we have the values of function of x, negative 5, 1, 7. Again, this is the range, and as you can see, the range is the set of real numbers. So negative 5, 1, 7 are all real numbers. Now we have negative 2, negative 5, 0, 1, 2, 7 as our ordered pairs. We plot those points, and this is the graph of function of x is equal to 3x plus 1. So that's how you graph a function. So one way is to use table of values.